Hello students, in this chapter, playing with numbers, we are going to learn the topic highest common factor. Now, first of all, let us see where we can apply highest common factor. Highest common factor is usually used to split things into smaller sections, to equally distribute two or more sets or items into largest group, or to figure out how many people we can invite, to arrange something in rows or groups, etc. Let us see an example. As meeting is arranged in assembly hall, I want to arrange, or I can say I want to divide students in rows, and that also in minimum number. The number of rows should be minimum. And in one row maximum students should be accommodated, and that also grade wise without leaving any student. Now let us see how many students are in each grade. Grade 6 is having 21 students, grade 7 is having 42 students, and grade 8 is having 56 students. So how we can do this sum? So first of all, we will find out the highest common factor of all the three numbers. On finding the highest common factor of all the three numbers, we get the answer 7. So 7 students can be arranged in one group, or say in one row. So how many rows will be there for grade 6? So for grade 6, as you can see in the figure, there are 3 rows. For grade 7, there are 6 rows. And for grade 8, there are 8 rows. So can you see the arrangement? Yes, in this arrangement, we have done the arrangement such that no students is left out, and minimum number of rows are there, and each student is accommodated grade wise. Now HCF helps us to find a given set of number without a remainder in each case. For example, as you see 14, 21, 28, we are supposed to find a number that can divide 14, 21 and 28 without leaving any number, and that should be the highest number, the greatest number. So highest common factor of 14, 21 and 28 is 7. So 7 will divide all the three numbers exactly without leaving any remainder. Next application. What is the greatest number which will divide 276 and 1242 exactly leaving no remainder? That means we are supposed to find the divisor, and the divisor should be the greatest number which will be dividing 276 and 1242 without leaving any remainder. So here also we can find the HCF. So HCF of 276 and 1242 is 138. So 138 is the greatest number which will divide these two numbers leaving no remainder. Now there are two ways to find highest common factor. First one is prime factorization method, and the other one is long division method. Let us see the prime factorization method. As we have seen in prime factorization method, we can use factor tree or division method. So here I will be showing you the division method. So we are supposed to find the prime factors of 144, 180 and 192 as per the question, and by division method. So on finding the factors, I will get the factor of 144 as 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3. That means 4 times 2 and 2 times 3. Similarly, obtain the factors of 180 and 192, that is the prime factors. Now, which number is common in all the three? That means which factor is common in all the three numbers? So as you can see, 2 is common in all the three numbers. Yes. So 2 is the common factor. Now again you can see the another 2 is common in all the three numbers. So another factor of 2 is also common. And at last you can see number 3, that is factor 3, is common in all the three numbers. So we are taking 3 as a common factor here. So 2 multiplied by 2 multiplied by 3 are the three factors which are common in all the three given numbers. On finding the product, I got HCF 12. So on dividing, so 12 is the greatest number which will divide 144, 180 and 192 exactly without leaving any remainder. So let us check it. 144 divided by 12 will give the remainder 12, will give the question 12 and remainder 0. 180 divided by 12 will give the question 15 and remainder 0. Similarly, 192 divided by 12 will give the question 16 and remainder 0. Let us see another example. By division method only we are finding the prime factors. So I have found out the factors of 150, 140 and 210. In that, factor 2 is common in all the three numbers and factor 5 is common in all the three numbers. So I am taking in common factor 2 and factor 5. So product of factor 2 and 5 is 10. So 10 is the highest common factor which is common in all these three numbers and which will divide all the three numbers equally without leaving any remainder.
Now, let us learn long division method to find HCF. Let us take an example. Here we are supposed to find the highest common factor of the three given numbers, that is 398, 542 and 436. Now arrange the numbers in ascending order. On arranging the number in ascending order, we will take the smallest number as the divisor and the second greatest number as dividend. Now here, on dividing 436 by 398, I got the remainder 38. Now this remainder will act as a new divisor and the old divisor will be acting as a dividend now. Now again on dividing 398 by 38, I got 18. Now similarly 18 will be the new divisor and 38 will become the new dividend. On dividing, at last I got 0. So the dividend for which I got 0 divisor will be the highest common factor. So highest common factor of 398 and 436 is 2. Now dividing this, taking this highest common factor and dividing the third number, if I get 0 as the remainder, then that number is the highest common factor of all the three given numbers. Now let us see an application for long division method of highest common factor. We are supposed to find a greatest number which will divide 615 and 963, leaving the remainder 6 in each case. Now by finding HCF of these two numbers, we will get the divisor which will be exactly dividing 615 and 963, giving the remainder 0. So first of all, we are supposed to remove 6 from both the given dividend so that we get the remainder as 6 at last. So removing the remainder, that is 6, from 615 and 963, we get the new numbers, that is 609 and 957. So we will find out the highest common factor of 609 and 957. By doing long division method, I got 87 as the highest common factor of 609 and 957. Let us check. So on multiplying 87 by 7, I got 650 and I'm adding 6, that is the remainder. Similarly, 87 multiplied by 11 plus 6, I'll get the another number, that is 963. So we can say that when we divide 615 and 963 by 87, it will leave remainder 6 in each case.
Now let us take another example. Suppose I want to make square beds for planting flowers on a plot of a land that is 54 meter long and 18 meter wide. Now what should be the maximum possible length of each bed? Okay, so we'll find here HCF of 18 and 54. So HCF of 18 and 54 is 18. So the measure of the side of a square bed should be 18. So if I am dividing the plot that is 54 meter long, so I'll get 3 beds, each of measure 18 meter by 18 meter. Let us take another example. Now here, for a group activity, I am organizing classroom supplies into a baskets. The classroom supplies are 42 glue sticks, 49 markers, and 35 rulers, right? So what is the greatest number of baskets I can make by using the supplies, and how many of each supply will be there per basket? That means how can I equally distribute all the supplies, and maximum how many baskets I will be needing. Again here we'll find out the HCF of 49, 35 and 42. On finding the highest common factor of 49, 35 and 42, we get 7 as the answer. So we will be needing 7 baskets. So in 7 basket, each basket will be having 7 markers, 5 rulers and glue sticks each. Here we are going to learn about co-prime numbers. Now what are co-prime numbers? Co-prime numbers are those numbers which do not have any other factor common rather than 1. For example, 2 and 3. 2 and 3 has only one factor in common, that is 1. Similarly for 3 and 4 also. Any two prime numbers are always co-prime. Co-prime numbers need not to be prime numbers always. There can be one composite number also. Two co-prime numbers are having HCF as 1. Twin primes. The number of set is said to be twin primes if the difference differ by 2 and they are prime numbers. For example, 3 and 5, the difference is 2. Prime numbers 5 and 7, the difference is 2. Similarly for prime triplet, a set of 3 consecutive simultaneously prime numbers differing by 2 is called a prime triplet. Here you can see the example 3, 5 and 7. 3 and 5, the difference is 2. 5 and 7, the difference is 2. Thank you.